So this is from Thinking with Math Models, additional practice for investigation 2, question 19 and 19a. And so when it says find the exact solution for each of these equations, it wants you to find out what the value of x is that makes this true. So you have two expressions that are set equal to each other. So I need to solve this in a way that gives me just one x, or an x on one side of the equation. So what I'm going to do first, and there's lots of different ways to do this, but I'm going to start this way. I have three x's here and a negative x there. So I have a negative 7 here and a positive 9 there. So I'm going to actually take this positive 7 or negative 7 and add a positive 7 to both sides of the equation. When you work with equations, you can always do the same thing to both sides, and it always will work. So 9 plus 7 is 16. I still have minus x here, equals 3x. And over here, the negative 7 and the positive 7 went away, because that means that equals 0. So now it's a little less complicated. I'm getting closer to the solution I want to find. So I have 3x here, and a negative x there, and a 16 there. And that I'm going to add x to both sides of the equation. And now I have 16 over here, that becomes 0, equals 3x plus 1x is 4x. And so now I can see that 16 equals 4 times x. Well, it shouldn't be too hard to figure out now that if I divide both sides by 4, then 16 divided by 4 is 4. And so x equals 4 for that problem. And I can check this problem. I can actually take that x equals 4, and I can just go ahead and say 9 minus 4, that's the x, equals 3 times 4 minus 7. See if that's true. 9 minus 4 is 5. 4 times 3 is 12 minus 7. So does 5 equal 12 minus 7? Yes, it does. 5 equals 5. So that solution for x worked. And that's kind of complicated, but that's how you solve for x, find a solution when you have two equations set equal to each other.